Vanakkam, welcome to Porvalan channel. Now we will see how to write program to add two hexadecimal numbers. So first we have to understand what are the numbers we have going to add before we write the program. So the numbers what we are going to add has to be decided. So let us just assume two numbers. Say an example, I am just going to add number 2, 9 and a7. So if we add is 9 plus 7 is actually 16. So it is 1 0 in hexadecimal. So 0 is here, carry 1. So 2 plus 1 is 3, 3 plus a is 13, 13 is d. So d0 hexadecimal is going to be our output, and these two numbers we are actually going to add. So to write a program to add these two numbers, so it is a simple program. So in this video I am going to explain what are the different ways we can use to add these two numbers. Okay, the first method. So first thing here we need to understand about the addressing modes and as well as the instructions of 8086, and as well as we need to understand the programming model what we are going to use in 8086 microprocessor. So the programming model I have posted the video number 7, and as well as the addressing modes of 8086 is there in video number 8. You can just go through my previous videos for clear understanding. Now we directly move on to write the program for adding these two numbers. First, so we can just choose an immediate addressing mode. In immediate addressing mode, the data are directly available in the instruction. So I am just choosing a random register. So that is the register. Say these are the registers available. Say AX, BX, CX, and DX, SI, DI, SP, BP. I am just leaving, because those many registers we are not going to use. Anyhow, we'll write it, not an issue. So BP, SP, we can just change the order, because that won't affect our program, not now. So this is AL and this is AH, BL, BH, this all we know. So here directly I'm just going to have my input data in the instruction itself. So I'm just moving my input data 29 to a particular register. Say I am just choosing AL. You can choose any register. So this is the 8-bit number, 29 is the 8-bit number. So we must choose an 8-bit register. We cannot actually choose AX. If we choose AX, that would be 16, or otherwise we have to write 0029. So that is how we need to take. Okay, so since it is only 2-digit number, I am just choosing only AL. BL also you can take CL, DL, AH, BH, CH, DH, anything you like you can take. So it is 29. So the first data has been moved to AL. So after this instruction, after the execution of this instruction, this register will be having 29. Next, the next data has to be moved. So move, say I am just choosing DH. Say an example, it's A7, second data, and both data are moved. So after this instruction execution, so here we will be having A7, and then next we need to add. So our program, first we are going to see addition program. So add, we have understood the instructions already. So for addition, ADD, and this one is the destination, so where it has to be stored. So I am just choosing a destination address as. So these two registers only have the values, so I am just choosing like AL comma DH. Now automatically this AL register becomes destination and DH register becomes the input. This both has the input value, and after the addition this becomes destination. So after this instruction execution, the result will be in AL register is, it's not 29, it is going to be D0. Okay, so D0, that is the result after this instruction, execution of this instruction. Now after this instruction we need to store the result. So for that I am just using some memory location. Anyhow, we need to store the result in memory location. I am using direct addressing mode. So there, say an example, 5000 is a memory location I am choosing. Since I know my output is there in AL, So I have to put AL. So here AL value is moved to 5000, 5000, the memory location, halt. So this is the way we can write, but this also can be written another way. So it is not advised to have your input in the instruction itself. It is better to have your input in the memory location, so that if you want to change your input, you can change it in the memory location instead of changing in the program. So the second method I'm actually going to write like this. So this is method 1 and this is method 2. Say example, first of all, before we write the program, we need to decide where we are going to keep our input data. Say let us assume these are the memory locations. Say I'm having my input value in 4000, that is here I'm just having 29 and the next 4001 I'm just having A7. So this is randomly I'm choosing the memory locations. So here say I'm just choosing AL and then the memory location. So here we are not moving it directly, the input immediate addressing mode we are not using. So before we move the value, we must specify where my so directly we can choose fine AL comma kind of 40 4000. So the value of 400029 is moved to AL now, and then next move. Say an example, I am just using BL. So it is 4001 because my next data is there in both the 4001. So now both the values are moved to AL as well as BL. Now I am adding AL comma BL. You can even put the BL comma AL because both the way you can add either A7 plus 29 or 29 plus A7. Both are correct. So nothing will be a problem. No. So here both are added and the result can be stored anywhere, your wish. So I am using to store say move say 5000 the AL. If I put BL, that is wrong because BL is having say what is it A9 A7, but AL only is having the output, that is the output value is D0. Okay, after this instruction execution, so it is HLT halt. So but here what we made is we have added one more instruction. See, we have another method to add two numbers. Either both the numbers can be, the data can be there in the register, or one data can be directly taken from the memory location. So we can reduce one instruction. Say the same program I'm writing like this. This same program I'm writing like this. So that is move AL comma 29. The first value I have taken. So here I have taken immediate addressing mode. So the next one is directly, instead of moving into another register, I am just adding AL value directly with A7. So A7 is the immediate value and it is added with the value present in AL and the result is stored back in AL. So this is also possible. So here the result again, we are moving into the memory location. I am moving back into a memory location HLT. So what is the benefit in this? We have reduced one instruction. This is gone. Okay, so this is the benefit. And the next in this also it is possible. Yes, so the same thing can be written like that. So it is like this. So it is move AL comma say 4000 and move add it is AL comma content of 4001. So the value of AL is added with the content present in, that is, which means 29 plus A7, that is what happens here. So again the result is there in AL. So we are moving back to the memory location we have chosen as 5000. So it is AL HLT. So these are the two different ways to write a program to add the same numbers. Again, this same program can be written in another method, that is indirect addressing mode. So in the indirect addressing mode, actually we have to decide which register is going to have our memory location. Say we have chosen, right? So 4000 I have 29, and 4001 I have A7. The result I wanted to store in 5000, that is D0, isn't it? Is it not? So this is what my decision is. So here what I have to do is I am actually deciding first. So it is method 3, the same program, it is written in this way. So here what I am going to do is, say first thing I am just going to have my memory address 4000 in one register, say SI comma 4000. So now this is 4000 is actually a data which is moved to SI is a 16-bit register. Okay, and now what I have to do, I have to get the value present in memory location 4000 to a particular 8-bit register, because my input value is 8-bit. So that is why. So again I am writing move, say an example, this time I am just taking DL not AL. So anyhow, to avoid confusion, so I am just using the same. So AL, but actually you can use DL, CL, DH, CH, BH, AH, AL, anything you can use, but it should be 8-bit because our value is 8-bit. So it is SI, instead of writing direct addressing mode, we are writing register indirect addressing mode. So now the SI is the register which has the value 4000. That 4000 is actually the address. So I suggest you to remember, wherever you see content, that is the bracket, square bracket or normal bracket, which means it is a memory location. It is not going to have a value, it is going to have a memory location. So the value, that is the memory location pointed out by SI, is moved to AL register. So SI is having, say an example, SI register is having the value 4000, that is moved to AL register, right? And the directly next we need to go to the next memory location. We have to address the next memory location, which means the next consecutive memory location only I have my next data. That is why. So for that I can just use INC SI, and then next directly we can add. So in the previous method 2 and method 1 I reduced one instruction. Similarly here also we can just do, say AL comma content of SI, which means the SI is pointing out now 4001. So SI, this instruction, right, this instruction is incremented SI to 4001 in the programming model register structure which I have shown in the previous paper. So here it is pointing out 4001. So the value stored in 4001 is A7. That A7 is added to the value there in AL. In AL we have 29 only. So 29 plus A7 is added, and the result D0 now is stored in AL. Understood? So next we need to store the result. Now it's we can use indirect register indirect addressing mode or direct addressing mode. So move say 5000 comma AL HLT halt. So this is a way we can write this program. So this is actually indirect addressing, register indirect addressing mode. And now these are the 3 different methods to do our program. First, next we can see subtraction. So in subtraction, so whatever we have done it already, like instead of addition we just write SUB, subtraction without borrow, addition ADD, okay, addition without carry. So SUB, subtraction without borrow. So all the instructions are same. Instead of ADD, if you just put SUB, it is subtraction without borrow, which means without carry, without borrow, in the sense we are actually not considering the previous carry stored in the carry flag or previous borrow stored in the borrow flag. So in this also the same thing, instead of ADD you put SUB. Here also instead of ADD you put SUB if you are liking to. So I preferred either this method. Here also instead of ADD you can just write SUB. I just prefer either this one or this method, okay, to write your program. So here I have just explained you addition without carry. We did not worry about the carry. So if we have addition of, say, an example, a2 and then 6 7, in the sense, now you see 2 plus 7 is 9, a plus a is 10, 10 plus 6 is 16, so it is going to be 1 0. So that is 109. So this, which means 0109. So there are going to be 16-bit number as output. But see, when we have added two numbers, say it is stored in AL register, but in case of this type of inputs, the AL register is an 8-bit register which cannot hold more than 8-bit numbers, so we will lose this number. So for this, a carry has to be generated, and that has to be saved safely so that we don't get the wrong output. So to get the proper output, we need to do this one. So this we will see in the next program. I hope you have understood well. Yeah, thank you.